Hello. In this video, we're going to start looking at inverse functions. Now, an inverse function looks like this. You have a -1 as an exponent, and it's read as f inverse of x. So the of x portion comes in with having it look like this. So f inverse is what this says, and then the of x is right here. This reverses the action of the original function. Now, here's the thing. Here's what a function does. It takes something from a set of x values and produces a new set of y values. Now, notice what's going to happen here is that if we want to go back in the other direction, we're going to have to reverse that. And the f inverse is the reverse of the original function, basically. So here's the thing. It takes stuff from this area and moves it back into the original area. Now, I used y here because technically we would use all these y values to get back to the original, but that is effectively what an inverse function does. Now, the term inverse actually is not that, or should not be all that unfamiliar to you, because of that -1 as an exponent. Think of it this way. If you have, say, 3 to the -1 power, what it does is it takes the reciprocal, right? It makes it 1/3. And this negative as an exponent, we usually say reciprocal, but there's also a term that we can use sometimes, and it would mean the same thing in the real numbers, that it is the inverse. Okay? In other words, this -1 is sometimes called the inverse of, so 1/3 is sometimes called the inverse of 3. It's also the reciprocal. The reciprocal is probably a better term for numbers themselves, but the -1 does serve the same purpose as this does here. By the way, notice that the -1 is written after the f and before the parentheses. Alrighty, now in order to have inverses, a function has to be 1-to-1. So a function f does not have an inverse unless it is a 1-to-1 function. I'm just going to abbreviate it as 1-to-1. In a 1-to-1 function, no two x's can be the same and no two y's can be the same. So to determine whether a function is 1-to-1, we use the horizontal line test. Which states that no horizontal line can intersect the graph at more than one point. This is very similar to the vertical line test. So let's use this real quick. We want to determine if the relation is a function, using the vertical line test, and if it is a function, state whether it is 1-to-1 using the horizontal line test. Now on A here, I hope you can see that it is in fact 1-to-1. Okay, so if we notice this, notice that I'll use green for that. All of these vertical lines only cross at most one point. Then we go on to the horizontal line test, and the horizontal line test, notice if you just draw a single horizontal line here, it's going to cross in two different places. Therefore, while this is in fact a function, it is not, however, a 1-to-1 function. Now let's look at letter B. Notice that if I draw a vertical line, that vertical line is going to cross in more than one place. Therefore, this is not a function. And because it's not a function, we don't care if it's a 1-to-1 function. So as a result, we're not even going to do the horizontal line test. Yes, technically it would pass, but we don't care. Now let's look at this one. For this one, notice it will pass the vertical line test, and notice that it will also pass the horizontal line test. Any horizontal line that you draw will in fact cross at most one time. So notice only once there, only once there, only once there, only once there. It kind of looks like there's a possibility that it happens in here, but just like with the vertical line test, it's going to be extremely clear if it is not one-to-one. For example, it would look more like this. This would clearly cross at more than one place. So this function, or letter C, is in fact a function, and it is a one-to-one function. Alrighty. Well, I believe that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.